the following. So we know that if we have a distribution where we know the mean and we know the standard deviation, then if we decide we're interested in a new variable like ax plus b, where we're taking our variable x, we're multiplying it by a number, and then we add a number onto it, that there's a new mean that goes with it. The new mean becomes this. So mu of ax plus b turns into a times mu of x plus b. Okay? And then we also know that the standard deviation changes. So the standard deviation of ax plus b turns out to be the absolute value of a times the standard deviation of x. This process where you take a variable you know the mean and standard deviation, multiply by a and add b, and then create a new mean and standard deviation, it's called a linear transformation of that variable. What else do we know? We also know that if we have two random variables, let's pretend we have a variable x, and we know its mean and standard deviation, and then we have another variable y, and we know its mean and standard deviation, do things like this. We can say we know the mean of the sum of the two random variables is just the sum of the means. Or we know we can get the standard deviation of the sum of the two variables by taking the square root of the sum of the variances. Right? And we've done that with the combining of SAT scores, right? We did it with the problem with the coffee and the lid, where the lid fit on the cup of coffee, and so forth. We also know that if we were interested in subtracting, we were going to do x minus y. We would just subtract the means, but this down here wouldn't change at all because we can only add variances. So that's always going to be plus there in between the two variances. All right, so what are we going to do next? We're going to take these two ideas and put them together into one problem. That's the plan. Okay. So let's make up a situation. So let's pretend there's a person, and we'll call the person Jack. Okay? And the person, Jack, is interested in two stocks. He's interested in stock X and stock Y. And he's going to make some investments with this money, hoping that it'll pay off for him. All right, so let's pretend he looks up about the stock X, and he finds out that on average, it's at a 5% rate of return with a standard deviation of 2.5%. This is a pretty safe investment. It might be something like a bond or whatever it may be. I do not give investment advice. All right. And then there's another stock he's interested in that has a higher rate of return, maybe 13.2%, but the standard deviation is also high, 17.5%. That's a more risky proposition. Okay? Now, he's not going to invest all his money in stock X or stock Y. He's going to do some combination of those two stocks. So let's pretend he decides to invest. We'll call the variable X, the variable I, equal to his investment. He does 30% of his investing, 0.3 in X, and then he does 70% of his investing in stock Y. This means that if he was going to invest $10,000, he's investing $3,000 in stock X, and then it's $7,000 in stock Y. Now, one more thing. Let's also pretend that both of these distributions are normal. That will allow us to answer some probability questions later on. Okay? All right. So the question is, what is the distribution of I, of his investment? Okay? Well, we know it's going to be normal because the two other stocks that he used to put together were normal. We just need to find the mean and the standard deviation. Okay. Well, the mean actually isn't that bad. So the mean of his investment, which we can write the mean of 0.3x plus 0.7y, is just this. It's 0.3 times the mean of x plus 0.7 times the mean of y. That's what it is. We shouldn't really be surprised by this, because we know we can just add means together, like we did when we went over the rules on the previous page. Okay? And then we know from linear transformations that if our variable is getting multiplied by a number, then that number just gets multiplied by the mean. So really, I'm just doing that twice. What I'm saying is the variable x is getting multiplied by 0.3, so its mean gets multiplied by 0.3. The variable y is getting multiplied by 0.7. So its mean gets multiplied by 0.7, like it did over here. And then those are our two means, and now we can just add them together. So that is mu of I. So in this case, we'd have 0.3 times 5% plus 0.7 times, let's see what we remember here, 13.2%. And this is going to be Jack's mean rate of return. 10.77? 7.74%. So that's his mean rate of return. Now, someone might say, hey, wait a minute. Why would he do this, right? Because by investing in stock A, or stock X, that is, by investing in this stock here, he actually lowered his mean from 13.2% to 10.74%. All right. So in order to answer this, let's take a look at what the standard deviation of I needs to look like. Now, we know by what we remember of combining random variables that if you want the standard deviation of the sum of two variables, you add their variances and you take the square root. That's what you need to do. All right, so if we go look at this variable, we know we want to add the variances. Let's be careful what we want to add. We want to add the variance of 0.3x plus the variance of 0.7y. And then we want to take the square root of that. But if we look back in our notes, we'll notice the only thing we have is we have the standard deviation of x and the standard deviation of y. We do not have the things that are required for this to work. So we know the standard deviation of x is 2.5%. We know the standard deviation of y, I think, was 17.5%. Okay? So then the question is, how do we take these things and convert them into the standard deviations we want? And then also into the variances we want. That's what we're looking to do. So let's look back at what we know about linear transformations. Here's the rule we have right here. It says if you want the standard deviation of a number times a times x plus b, it's the absolute value of the number you're multiplying by times the standard deviation. So in our problem here, the standard deviation of 0.3x is going to be the absolute value of 0.3 times the standard deviation of x. But we know that. So it's going to be 0.3 times 2.5. Let's do the other one. So in the same fashion, this one's going to be absolute value of 0.7 times 17.5%, or 0.7 times 17.5%, which remember this is going to give us a percent. These two numbers are, all right, so this turns out to be 0.75. This turns out to be 12.25. Okay, well, that's great, because now we can find that variance of the investment. See, we have these two pieces now we want, because we have the standard deviations. So the variance of our investment would be the square root of 0.75 squared plus 12.25 squared. So we can figure that out. So I'm getting about 12.27. So notice, if we go back for a little bit, I had made the comment before that if you looked at the mean of this distribution of the investment was 10.74%, which was less than the mean of just investing in Y. If we had just invested in Y, we would have had a return of 13.2% on average. But Y's standard deviation is really big. It's 17.5%. But this new standard deviation, notice how it's a little bit smaller. It's 12.27%. So even though we have a lower mean, we also have a lower standard deviation. Okay? So now we could ask the question, what's the probability that Jack's investment has a rate of return that's greater than 0? That's what we want to know, right? When you invest money, hopefully you get something for doing that. Okay? Well, we know the distribution is normal with a mean of 10.74 and a standard deviation of 12.27. Okay? We only know it's normal because the original distributions we added together were normal. So now we can draw a normal distribution, mark off the mean of 10.74, and then think about where 0 is going to be. Well, A full standard deviation away would be 12.27. So 0 isn't quite a full standard deviation away. It might be over here somewhere. Okay? And we want to know what's the probability that we're going to do better than 0. So there you are. And now you can answer this. You can do a z-score. Z equals 0 minus 10.74 over 12.27. You can get that answer. Okay? So this is about negative 0.88. I'm rounding to the second decimal place so I can use the table, our normal probability table. So if we look that up, negative 0.88, I'm getting a number of about 0.1894. So that's the area you'll find in the table, 1894, sorry, that. Right, but keep in mind, that's the area to the left of that z-score. So this area here is 0.8194. We want the area above that. So the desired area there and here is going to be 1 minus that number, or 0.106. 8106. Okay? So he has an 81% chance that his investment's going to give him some kind of positive rate of return. Now, it might be fun to compare this. Should he just have invested in Y? That might be a fun question to ask, right? So he was just going to invest in Y. Let's pretend he was going to do that. Say, well, you know, I want to go for the big return. Let's just invest in Y. So what's the probability the variable Y is greater than 0? Well, Y is just that one investment. If I had a distribution that was normal, let's remind ourselves, the mean of 13.2 and a standard deviation of 17.5. So mean 13.2, standard deviation 17.5. So draw a normal distribution, mark off 13.2, and find 0. So 0 is over here somewhere. Okay? Right? So in this case, we're going to do a z-score. It's going to be 0 minus 13.2 over 17.5. Okay, so you might notice right away, this is not as many standard deviations away as in the other question. The other question, we were negative 0.888 standard deviations below the mean. In this case, I don't think we're going to get that far. Negative 13.2 divided by 17.5 gives us about negative 0.75 standard deviations below the mean. So we still want this area, but this z-score is not as far to the left. And when you look it up, negative 0.75 is a z-score. You get an area of 0.2266. So this area in here is 0.2266. So the desired area is 1 minus that. 0.7734. Or there's a 77.34% chance that his investment's going to give him a positive return. So what you'll notice is that while the average return in this joint distribution, this investment strategy where he decided to do 30% in X plus 70% in Y, while it had a lower average rate of return, the probability you got back something positive was higher, right? But if you invested just in Y, the Y has a higher average return, but it's a little more volatile, so there's less of a chance that you're going to see a positive return on your investment.